Hi. In this short video, we'll briefly look at the .NET Framework overview. So this is what we will be knowing at the end of the session. So we'll try to understand overview of the .NET Framework. So we'll start with an introduction of .NET Platform, overview of the .NET Framework, and what are the core components that made up the .NET Framework, and the important jargon that we need to understand and the features that we need to understand about the .NET, the MSIL, CLS, CTS, assemblies, CLR, the common language runtime, and the .NET CLR, which is the heart of the .NET, and the difference between the managed code and unmanaged code, and what are the different stages the .NET program goes from coding to running, and finally we'll look at a simple demo. So what actually the .NET is? So .NET is a platform. .NET is not a language, so it's a platform which basically from the Microsoft for the software development. It is a unified technology for the development for building wide variety of the applications. So the applications can be from as simple as the character user interface application to the applications which can run on web, GUI, mobile, server, cloud-based applications. So basically this is a kind of a platform where different kinds of .NET languages execute upon. So we have to understand one thing, that .NET is not a language. .NET itself is a platform. The word .NET and .NET Framework are interchangeably used. Both convey the same meaning. So this is what the description that comes about the .NET Framework from the MSDN, the Microsoft Developers Network. So the .NET Framework is a managed execution environment that provides a wide variety of services to its running applications. So as discussed in the previous slide, it basically the execution runtime environment which basically provides services for the variety of running applications that are running on the .NET. So it majorly consists of two important components which are termed as CLR and FCL, the common language runtime and the framework class library. The common language runtime is the execution engine that basically handles the running of the applications, and .NET Framework class library, also called as FCL, is the collection of reusable tested classes that are delivered from the Microsoft as part of the .NET Framework release. So as a developers, we can make use of these FCL classes and we can try concentrating on developing the core application logic rather than working on the low level functionality which is already provided from the .NET Framework class library. So .NET is an object-oriented programming model. So it's a purely an object-oriented programming model, and it will help the developers to create internet-based distributed systems. Majorly, like we can develop web services, we can develop web applications. We have a concept called WCF, Windows Foundation, Windows Communication Foundation, and many more applications that can be developed using the .NET Framework. So the two important terminology or two important features that are more helpful for the .NET platform are the platform independent and the language independent or cross language interoperability. So we will understand about these two terminologies more in this particular slide, in this particular video. So as told, this is a short introduction. We are not going to discuss anything in detail about the .NET Framework. So we will try to concentrate on the core features that are provided out of box as a functionality from the .NET. As told, the platform independent and the cross language interoperability are the two important terms that we will try to understand here. So basically this provides a platform independent framework that enable developers to quickly build, deploy and manage. So web-based applications, those can be smart client applications or XML web services, or this can be mobile-based applications. So we'll try to understand more about platform independency and cross language interoperability, language independence or interoperability in the coming slides. So the platform independence feature basically enables business to quickly integrate their systems, information and devices, thereby helping users collaborate and communicate effectively. So So in this slide we will understand what are the core components that .NET Framework comprises of. The common language runtime, so also called as a CLR, which is considered to be the heart of the .NET or the lifeline of the .NET, because all your .NET applications execute in the CLR. And next is the framework class library. So again, it's a set of reusable and tested classes which are delivered out of box from the .NET Framework. So we'll be having a different kinds of classes depending upon the versions that .NET has offered and enhancements. And there are also the different compilers and tools that comes basically with the .NET Framework. Okay, so we'll try to understand the overview of the .NET Framework. So where actually it stands, which component of the .NET stands at what particular level within the system. So at the core we have the operating system. So we know like operating system is the user interface. It's a kind of interface between the user and the hardware. So operating system, it takes the main responsibility of managing the resources and the processes and users of the machine, and it also provides services to some kind of application like threads, input output, COM plus MSMQ, IIS, Internet Information Services, and Windows Management Instrumentation, WMI. So these are the core things that operating system takes care of. So on top of the operating system, the CLR runs. So CLR also runs like a process within the operating system, and the CLR basically provides a runtime environment for the .NET applications. So CLR has several responsibilities. So we have dedicated slides where we are discussing about what are the different kinds of responsibilities that CLR is supposed to achieve. So we will be seeing that in the coming slides. So the main features of the CLR is basically it manages the execution of the .NET code, and it manages the memory. So it basically takes care of the memory management, concurrency, security, which code to execute, which code not to execute, and the role-based security. So there are different responsibilities and features that are coming out of this CLR. And next we have the base class library. So it's nothing but a rich object-oriented library with lot of fundamental classes. So the classes vary from like input, output, collections, text processing, network, security, multi-threading, and many more. So there are lots of classes that are part of this particular base class library. And on top of this, we have one more layer which is called as a data type. Basically called as a data type because the classes which are part of that particular level of framework basically help us to communicate with different kinds of data sources. So if you look at this particular slide, we can see like we have put the different features in the stack way. So it basically says like the feature which runs on top of that will make the use of all the features which are running in the bottom. So which means that the ADO.NET, Link, and XML in turns make use of the base class library features and then deliver a different kinds of functionality. So the ADO.NET is basically used to communicate with the relational data sources, and LinkQ is again a different kind of concept that has come out from Microsoft, which is called as a language integrated query, where they have tried to bring a commonality in querying the different kinds of data sources using the common syntax. So what actually the commonality is basically, if you want to query a SQL based, or if you want to query basically a relational data store, we always use the SQL commands like select commands. And if you want to query the XML, we have to use the XPath commands. So but using a link, so they have created a kind of a common layer, so where irrespective of the type of the data source, you can try to access in the common way. So since you're integrating that query basing in the language, it's called as integrated language integrated queries. So this is about the data type, and .NET offers a wide variety of XML classes which will help us to work with XML smoothly. And on top of the data type, we have the communication and workflow type. So this WCF and WWF. So WCF is basically like Windows Communication Foundation, and WWF is basically called as Windows Workflow Foundation. So these two are the different technologies which will help us to achieve different kinds of communications. Like Windows Communication Foundation has a capability, it's like in enhanced versions of the web services. It has a lot of features where it has helped to ease the the communication features, and on top of these communication workflow layer, we have the GUI based technologies like ASP.NET, which is used to develop the web based applications, web forms. We have it also has an architecture called MVC and Ajax mobile internet toolkit, and then we have Windows Forms, which we can use that set of classes to develop the desktop based applications. Then we have WPF, Windows Presentation Foundation, rich GUI based desktop based applications, and then we have Silverlight, and again like the rich graphical web based applications. So on top of this we have the .NET technologies. So this is the primary reason we are saying .NET is a framework. It is basically a platform which is providing the environment for the different .NET languages to execute within it. So C hash or C sharp, C++, VB.NET, J hash, F sharp. These are different kinds of .NET languages. So why we specifically call these .NET languages? Because all these languages follow a set of rules defined by the .NET framework. So that is how .NET is capable of understanding the different kinds of languages. We'll try and understand what actually we mean by that. So that is where in the very first slide we have seen certain terminologies like CLS, CTS, so MSIL. So that is where these all different kinds of technologies can easily work with each other because of the language interoperability features. That's what we are going to see in the coming slides. So before going to the next slides, now we will try to understand the jargon what we are trying to discuss in this slide now. The CLS, CTS, assemblies, CLR. So all these combination of terminologies basically achieve two important features: the platform independent and the language independence. So CL is nothing but it's a set of rules that are delivered by the .NET framework, which is called as a common language specification, which means any .NET language that has to run a .NET framework has to abide the rules that are defined by the CLS. That is where the common language specification comes into picture. The common language specification holds one more terminology within it, which is called as a common type system. So .NET itself has a common type where different languages might have their own type, own variant of types. So which means like you can have a different kinds of types in C# and you can have a different kinds of types or names in VB.NET, but at the end ultimately those types are mapped to the common type system that is defined in the .NET framework. So we're not going to discuss these in detail, as this is a quick and short introduction video. We're not going to go into detail and understand which type is going to map which type in the respective language. So next comes the assemblies. So assemblies is nothing but the deliverables of your .NET development, which means if you create if you code something in your .NET and you compile it, which means when you compile it, you are going to generate an output which is called an assembly. So those are two types of assemblies that can come here. So there are two types of output that come here, which is called as an EXE or DLL. So both are termed as assembly. So assembly basically holds two different information within it: the MSIL code and the metadata. So we will see what actually the MSIL code is, which is called as a Microsoft Intermediate Language code, and the metadata. So metadata is nothing but the data about the data, which will describe the components which are within the MSIL. So all the assemblies in .NET are the self-describing, which means they hold information about themselves. So we will see how actually this is helping us. Next comes the CLR, the Common Language Runtime. As we are saying, this is a language. Common Language Runtime is the runtime execution environment which can host the runtime for the .NET based applications. Platform independent. So what actually we mean by platform independent, and why this particular term is important, and how actually .NET is achieving this. So before the .NET era, so we have some important and more popular languages like C and C++. So when you create a program in a C language or C++ language and you compile the program, the output of your program is basically a kind of an EXE, which is basically directly converted into the machine specific language, which means all the all the human readable instructions are converted into a machine readable instructions directly. So since we have different kinds of operating systems and different kinds of process architectures, so the instructions which are targeted for one particular operating system and one particular process architecture cannot be easily ported into other architecture. So which actually means if we have a C program which is compiled and created and compiled on Windows operating system, and if you try to execute that piece of code back, that deliverable which has come as like an exe, if you try to run it on a different operating system like Unix, it might not work 100%. So it depends upon the different kinds of data types we are using, because the memory architecture, the way the operating systems understand the things are a little bit different. So that is where the challenges have come, because the codes written on one particular operating system are not easily portable. So for different kinds of operating systems, so developers has to create a different flavors of the code, which actually cost the developers in terms of the development, and also in terms of maintenance it is a little bit cumbersome. So then comes the language called Java. So most of the people have known the Java basically offers a feature called as a platform independence. How Java has achieved it is basically, instead of converting your the code which has written directly to the machine code, they have come with an intermediate format called as a bytecode. Same implementation is made with .NET. So whenever you create your program in one of the .NET language like C# or VB.NET or JHash, whatever it is, when we create and we compile it, the output will come in the format called MSIL, intermediate language code. In simple, it is called as IL. It is called as IL code. So this code is not specific to any operating system. This code can be understood by the CLR. So we will be having a different kinds of, we will have a different CLR developed for Windows based operating systems with different, and we have a different kind of CLR that can be developed for Linux. So now when this MSIL code is fed into the CLR, then the CLR will do a next set of compilation in the MSIL. So that is where we have a word called JIT, just in time compilation, where it compiles MSIL code to native machine instructions depending upon the CLR that is running on the machine. So this is how the language, this is how the platform independence is achieved. So which means, so you can write your programs on a Windows operating system on 64-bit architecture, and then you can move it to a different 64-bit architecture or Linux system, and it can easily run on. So that means irrespective of the platform, your programs are running without any kind of problem, which means your code is easily portable to any kind of platform. That is where the platform independence are come feature from the .NET. And next important feature which is specific to .NET is language independence or language interoperability, which is also called as a cross language interoperability. So this is one of the big advantages of the .NET framework, and this is one of the objectives of the .NET framework. So so why actually Microsoft have come of this particular feature? Because before the .NET era, Microsoft has a language like VB, VC++, which are already popular. So whenever a language is being created or whenever a new language is coming into the market, it should be easy for the developers to migrate, because if it's all in a different kinds of languages, then you will have a less developer base that will be migrating to this. So which means the product utilization will be less. So if you don't have developers, then it will be difficult for any product to be built upon. So so Microsoft have come out with an idea like this is where the language independence feature has to come into picture, which means you can write your piece of code in any language, and that piece of code can be used in any other language. So in simple terms, you can create set of reusable classes in C#.NET, and you can use that reusable classes in the VB.NET. Okay, so which means VB will not be aware like these are created in some alien language. More now it will feel like this is like a native. How actually it has been achieved? Again, it is achieved because of the common type system. Why? Because when you compile your codes, the code is coming into the form of MSIL. So MSIL, when it getting converted into MSIL, it follows the rules of CTS, and the respective language type will get converted back into the common type. And so since this is having a common type and the assembly is also having a metadata which can describe the properties that are available within the assembly. So any other language can be easily reuse them. So that is where the language interoperability has come into the picture. So these are two important features of the .NET: the platform independency and the language independency. So now let us understand the stagings from coding to running, and then I'll come back. So we will try to understand, we will try to map the terms what we have seen in the previous slide here. So we can write our piece of code in the .NET language. It can be C# language or VB language or ASP.NET, any kind of technology that we can create the program and then compile. Then the output will be an exe or DLL depending upon the program, depending upon the type of the project and type of work we are basically doing. So this exe or file is basically termed as an assembly. So your assembly is nothing but output of your compiled code. So which is the assembly, as told, assemblies are in the form of MSIL and it has a little bit of metadata in it. So once this MSIL is generated, this MSIL will be fed into CLR. You can see here you have different types of CLR you are seeing. So CLR, mono CLR, compact CLR. So mono CLR is an open source project from a set of people who has developed the CLR to run on the Linux operating system. So now these CLRs can understand the MSIL code. Then when the MSIL code is fed into the CLR again does the compilation as needed. That is the reason it is called as just-in-time compilation. And then it converts the IL instructions, which means intermediate language code instructions, into the native machine instructions, and the code will start executing. So hence CLR is the one which is providing you the execution runtime, and CLR has to take a responsibility of managing all your code. The basic responsibility and main responsibilities of CLR is what we are going to see in coming slides. So like it is responsible to manage the memory. So before .NET era, like when you create a program in C++, we basically use the concepts called constructors and destructors to allocate the memory and deallocate the memory. So which has created a problem like memory leak, which means the programmer, if the developer has not taken proper care of the destructing the objects which are not in use, so we would end up with shortage of the memory and our program would fail with out of memory issues. So these are taken care in the CLR. So CLR uses the concept of garbage collection, which basically looks for the objects which are not in use and then shut them out from the memory and freeing up the memory so that resource can be shared to some other objects. So this is how the stages from coding to running. So basically you create the code in one of the .NET language like C#, compile it, then comes the MSIL, and the MSIL will be fed into one of the CLR, and the CLR will execute your code. So now let us see the responsibilities of the CLR. So the main responsibility of the CLR is the execution of the IL code and the JIT compilation. In JIT is nothing but just in time, which means as needed it will compile the MSIL code back to the machine instructions and then execute your piece of code. Next responsibility is managing the memory. It has to take the responsibility of managing your memory, allocating the memory, removing the deallocating the memory, and managing the application resources. It has to ensure the type safety. So as we know, .NET itself has the common type system, and .NET is basically a strongly typed language, which means the type, it will not allow for any kind of the data truncation, or it will not allow for any kind of incompatible type castings. So it will make sure the types are used as desired. So that is where the type safety has come into picture. And then CLR interacts with the operating system. That is where it passes the instructions that are to be executed from MSIL code. It converts back to machine specific code and passes it to operating system for the execution. And CLR also provides the responsibility of managing the security, basically which code should access what kinds of resources, and which person, basically which user should have what kind of access, the role-based security. It takes care of the code execution security. And then the exceptions, the runtime errors, the handling of those exceptions, and managing the concurrency, where we have the parallel execution, like we have multiple threads, the thread-based applications. That is where managing the concurrency, CLR takes the responsibility of it. And it also manages the application domains, so and their isolation. So how one application domain is different from other application domain. So application domain itself is a different, so it's a big concept to understand. So we're not going to discuss that in detail here. and interaction with the unmanaged code. So we will see the difference between managed code and unmanaged code. Then this point makes a little bit of sense. And supporting of the debug or the profiling of the .NET core. These are the core responsibilities that CLR performs, and these points whatever we have seen in the graphical view in this slide. So these are the core components that you run within the CLR, the class loader. So which is the main component which loads the classes and then starts the executions. And we have MSIL to native compilers, that is where the JIT fits in, and we have the garbage collection, that is where the memory management fits in. Then we have the code manager, this is where the code execution fits in. Security engine, this is where the code security, code access security is being achieved. Concurrency is managed in the thread support. Type checking is managed in the type checker. Exception handling is managed in the exception manager, and controlling the unmanaged code is managed in the COM master. So we will see what actually it is, and it also has the base class library support. These are the components internal to the CLR which basically help to achieve the CLR's responsibilities. So what actually a managed code and what actually an unmanaged code. So in simple terms, managed code is the code which is running under the CLR, which means the code which is controlled by the CLR, and unmanaged code is the code which is not controlled by the CLR. So when the code is controlled by the CLR try to take the responsibility of the whole code, like managing the memory and all the stuff, all the responsibilities what we have seen in the earlier screen. But when it comes to unmanaged code, that piece of code doesn't run under the control of the CLR. So this is basically like why we would basically want an unmanaged code, because if you have a set of business rules or piece of reusable code which is already developed and in the language which is not part of the .NET, which means which is out of the .NET languages, like it can be kind of mean that will be application code, but still we want to make a reusable of it. So .NET has provided that feature, that is where the unmanaged code can be run in the within the .NET CLR environment, but it does not take the responsibility of this. So in simple terms, any programs written in .NET language are compiled to a managed code, so which is also called as an IL code. And as we say, the managed code is basically packaged as assemblies. It can be exe or .dll files which holds the MSIL and the metadata. So this is how the MSIL looks. So I've just given a small screenshot, and we will try to see look at the MSIL. So using it, we have in different kinds of utilities that are available. So now so we'll try to understand a little bit more about MSIL. So as we say, MSIL is Microsoft Intermediate language code, and this is basically it's basically a low level language for the CLR. So IL is a low level language for CLR. CLR reads this particular IL and then it converts to the machine specific instructions. So this IL basically holds independent CPU instructions, like different kinds of calling methods like loading and storing strings, arithmetic and logical operations, exception handling, etc. It has a lot of independent set of CPU instructions. So the MSIL is basically converted into the current physical CPU by the JIT. So that's what we are saying. The JIT takes the responsibility compiling back MSIL to the CPU specific instructions. So before we go a little bit of before we go and look into the demo, let us try to understand what is the compilation. So which brings a term called compile time, and what is execution, which brings a word called runtime. So these are two important terms to understand: the compile time and the runtime. What actually happens in the compile? So in the compilation stage, what basically happens is, which means we are talking what are activities that are comprised in the compilation. The source code will be converted to the MSIL by using the respective language compiler. So when I say respective language compiler, every language will have its own compiler. So we have, for C# we have something called as a CSC, which is like C# compiler, and for VB.NET we have something called as a VB compiler. So this, depending upon the type of language we write and type of the compilation we do, this CSC will read the source code and it will convert it will perform some basic checks, and then it will convert the successful code to the MSIL. So the MSIL which is generated for the similar kind of program in C# and VB.NET will be one and the same. Why? Because those languages has to adhere the rules specified by the .NET framework, and MSIL should land into the same kind of CTS. So now we understand, like, from source code, then using respective language compiler, it comes to MSIL. So this is where our compilation phase has completed. Now in the execution phase, so this is basically what we term as assembly. So which basically holds the metadata and the code, and when this MSIL is given to the CLR, the execution runtime, then JIT comes into picture. The just-in-time compilation reads the MSIL code and then convert it to machine specific code. Okay. So this is where how the MSIL ultimately go into the machine code based instructions. So now we have the MSIL now, and we are trying to execute the CLR. So what are the different kinds of steps that can happen is basically, so it starts with your class loader. So now we are discussing about the CLR executing MSIL, how actually it executes the MSIL. So first step is your class loader, which loads the class using the class libraries, and then it will do some kind of verification whether its code is trusted or not, and it will verify the code basically, and upon verification then it hands over the code to JIT compiler for the compilation, and then the code becomes, the managed code is basically put into execution. Okay, so this execution part will basically taken care by two components within CLR, the code manager and the security engine. Right? So this is how the CLR executes the code. It using the class loader, so it will load the class, respective class, verify the code whether the code is trusted or not, and then you do a JIT compilation on it, just-in-time compilation, convert it to the machine language code. The managed code is converted to execution based code, and then the code manager and security engine take the responsibility of executing the piece of code. Okay, so that is about how the MSIL works. So now we'll look at a simple example. So what actually we will try to achieve in examples I'm trying to create a very fairly simple, like always any language will start with like hello world programs. So I'll be creating one console based hello world program, and then I'll be creating one GUI based hello world program. Okay, so just to demonstrate the two different kinds of programmings what we can do in the .NET framework. So for developing the .NET based applications, so we use an IDE which is called as Integrated Development Environment, which is called as Visual Studio. So currently I am using the version of Visual Studio 2010. So once you install your Visual Studio 2010, so you can go to your all programs and you can find the folder Microsoft Visual Studio 2010, and you will have this symbol 8 in horizontal way. Click it, that brings up your Visual Studio programming environment. So we have a different menus. This is the tool most of the .NET developers will spend their time in developing the applications within this. So we'll quickly create a new project. So new, we'll go select for the project, and Visual Studio will have lots of templates which are called as Visual Studio templates, which will help us to pre-build the structure of the particular project. So for the kind of work we are trying to do. For example, if you want to build a Windows based applications, so it might need different kinds of classes that to be referred from the core framework class library. So so it is not mandatory like you need to have Visual Studio to develop the programs, but you can also develop the programs in plain Notepad and compile them using the respective language compiler. But using the tools like IDEs and Visual Studio, it will fast your development because it has lots of features like debugging features, IntelliSense, and the project templates, which will bring the developers productivity more. So now we'll go and select the console based application, and so I will call this as Hello World console project, and my solution I would say Hello World master. So what is the difference between a project and a solution? Solution is nothing but it's a collection of a project. It's like for addressing one particular problem, we are going to create a solution. Within the solution we might having a different kinds of projects. So here I have a solution name called Hello World master, and my project name is Hello World console, and you can see I have selected a type of project called console application. So before going to this, let us quickly walk through on this. So you can see here there are different kinds of .NET frameworks that are provided. These are basically for the backward compatibility. So from .NET 2.0 to 3.0, 3.5, .NET Framework 4, you can develop any kind of framework based applications. So you have to select the target framework here. So now I have selected .NET Framework 4. And if you see here, currently you are seeing something called Visual C#. So when I set up my Visual Studio, I have set up only for Visual C# project. That is the reason I am seeing only the Visual C# based templates. If you install Visual VB.NET and C++.NET, then you would see a different folders like Visual Basic and Visual C++. And within this language, you can have a different kinds of applications. Like you can have Windows based applications for developing GUI which runs on the Windows, and you can have web based applications, ASP.NET applications, and you can also develop an Office based applications, the plugins or add-ins for the Microsoft Office, and we can develop the cloud based applications, and we can develop SharePoint based applications, Silverlight based applications. So every kind of application has its own kind of templates, because the different kinds of base class libraries they refer will be different. So now since we are going to develop a simple console based applications, I have selected for console and it is showing the Visual C#, and then click OK. So this creates a project with the name Hello World console, and it will add all the necessary references. You see here, so it has created, and at the bottom you can see here it is showing me like creating project Hello World console project creation successful, which is towards my bottom left, and we can see here it has created me a project which is called Hello World console, and it has given me one particular file called program.cs. Since we are coding our program in C#, it is coming as CS. If it is a VB program, it will be VB, and this particular program might use the different kinds of framework class libraries. If you want to make use of XML, you have to access this particular namespace. Okay, so I'm going straight into this. So this is the structure that C# program will look like. Since we are trying to so the objective of this particular program is we want to print a simple word onto the screen. Say console dot. See, this is what the beauty of using the IDEs and the advantages. So this is basically called IntelliSense, which is helping you with a lot of different kinds of properties and different kinds of methods that are part of this particular console class. Okay, so there is no need for us to keep remembering all the classes. So I'll go and select a method called writeLine, and this is again the IntelliSense. It shows there are overload. This particular writeLine method is overloaded, and there are 19 versions of overload. You can click the bottom arrow, and it can show you. It is showing you different kinds, and it is trying to give a different. It is trying to give the little bit of help over here. So since we are going to print a string, simple string, we are printing hello world. Okay, so all strings must be enclosed in the quotes, and then to pause the program for little, I am using readline. So now my program is ready. Click on the save. So to compile the program, so you can right click on this project, click build, or you can go to the build menu. And in the build menu, you will have an options for building a solution, or you have an option for building the specific project. So I would say build hello world console, and the output window comes out, and you can see output window will tell you the result of your compilation, whether it has been successfully compiled. If it has been successfully compiled, what is the deliverable that has come out of this particular project. So you can see here the build is succeeded, which means it successfully compiled, and it says at this particular location your assembly hello world console.exe has been created. So what is the major difference between an exe and DLL? So DLL in the full form is called as dynamic linked library, and exe is basically called as executable. To keep it simple, exe has a capability to spawn its own process and start executing, which means it has a capability to kick off the execution, but DLL doesn't have the capability to kick off the execution, which means if a DLL has to be used, it has to be hosted into one of the executable and then start executing. So let's not go much detail into this. So now we basically understand what is the difference between the exe and DLL. Okay, so the output of this particular program is basically an exe. So how it is able to identify like whether it has to generate the exe is this particular method basically gives the hint that it should be an exe. Okay, this is also called as an entry point, which means your program execution basically starts from this particular point. Okay, so now we have built the program and we can see the output, it is successfully executed. Let us go ahead and see on the file system what are the different things that have come out of this particular execution. So I have a folder called bin, so which is a shortcut for binary, and I have a folder called obj, which is for objects. Let us go into binary folder, and since the target runtime what we are using is a debug here, I can see it's coming as a debug. Within the debug I have the hello world console.exe. I can double click this and you can see it is executing. It's because exe has a capability to spawn its own process. So this is again, as we told, this is an assembly which is in MSI, which is in intermediate language code. It is not directly the machine specific instructions. It is in a low level language which can be understood by the CLR. Okay, so now we have created a simple solution here, so which is printing on executing this, which is printing me the string whatever I have given in my program. So now let us go ahead and inspect how actually IL has been created for this piece of code. So I have a tool here which is called as ILSpy, which is an open source. You can download ilspy.org. So this particular tool has a capability to decompile the MSIL back to the respective language or show the IL as it is. So for this I will go to file menu, I will click on open, and then I have to target my exe. So the core, our project is hello world solution, hello world console. Go to binary, go to debug, select exe and click open. You can see here you have an options like C#, VB and IL. Okay, so I have created my program in C#, but I can decompile the program back to VB. You can see here this is how my program looks in VB. So how it is able to do, this is where the language interoperability has come into picture. So since when we compiled our code, the code has been converted into MSIL, intermediate language, which basically follows certain rules that are defined, converted to common CT system. So this, the decompiler has read the MSIL and converted back instructions, because it understands the mappings between how a type in VB.NET is mapped to what type in the common type system. So it has read the MSIL and it is converted back to C# to the VB. You can convert your code back to C# also. You can see here same piece of code what we have written here with the 2 lines. I can see the same piece of code here, and with the exactly the same lines of code. Okay, so now let us go and select IL. So this is how the IL looks like. See the lines of code that was come out here. So these are the instructions. Like we have instructions like load string, which actually loads this particular string. These are all the MSIL instructions. This is how the IL code looks for the piece of program what we have created. Okay, so this is how our IL code basically looks, the main method. And you can see here it has put something called as an entry point, which means your program execution always starts from entry point. So what is specific about the entry point? Because when you have a different kinds of methods, and so you should give some kind of hint to the runtime saying where actually you should start execution of your program. That is the reason we should always have a process, and that process should have an entry point defining saying from where I should start executing and should go on. So we can see here we have created simple console based application. You can also debug your applications from here. So you can select, so we have something called as a breakpoint. If you bring your cursor towards your left and on this white line, and if you just click on here, you can see a pink color dot that will be created here, maroon color dot, and the whole line will be, so this is where it's a breakpoint, which means when the code is executing, your code will stop there till further action that is taken by the developer who is debugging the piece of code. So when you select this, you can go and click the start debugging option here, and you will see your code stops at this point, and it will highlight you in the yellow color saying I am waiting for the next set of action that has to be continued from here. And you can see there is nothing print here because this piece of code has not been executed at all. And we have options like step in, step over. Okay, so I'll select this step into, and this instruction has been completed, and I should see that line of code that has come back to the console here. And if I click it again, next set of action has happened and my program execution is completed, and you can see that yellow line has gone because there are no more lines to be executed. So this is how we can make the benefit of this IDE, because it has lots of debugging features. So now let us go ahead and create another Windows based application, simple Windows based applications, where in this application we have seen the character based user interface, like your text that is coming into black console screen, the old type of applications. And now we will go and create Windows based application. For this, right click on the solution, go for add and select the new project. This time we will select a different kind of project, Windows Form Applications, and let us call it as Hello World Windows. Click OK. So this should create me a different project now, and I can see an extra one GUI based file has come here, which is called as form1.cs. Let us try to compare the project structures. We will understand here. So both has the properties, both has the references, and at top of both have the programs. Okay, and this Windows program, the Windows project has something extra. So let us go ahead and expand the references. Okay, this is where you will see a difference. You can see here there are set of classes like system.drawing, system.windows forms, different kinds of libraries that are added into references in the Windows based application, but which are not available in the console based applications. Okay, so this is because the project template which is built for developing the Windows based applications, and we know all the classes that will be used for Windows based applications are coming from these particular namespaces. So these namespaces on this set of classes, namespaces, libraries are already added to the references. That is where the project templates will help us. Okay, and next thing you can see. Fine. So now we will change the form name. You can right click on here, click on this rename, and we will say we will change the form name to Hello World. Okay. Still you can see this is coming as a form 1. You can select on this your form, and for the text you can change it to Hello World. Okay, so all the GUI based applications basically will be designed in a way to respond for the events. Okay, so what actually an event is? For example, when we are interacting with the operating system, when you want to open a folder, you go select the folder and double click it, which means you are sending an event of type called double click. So there will be an action associated with that event to perform the work for you. So similarly, since we are trying to develop a GUI based application here, so we have to follow this event based modeling. So what actually I will do here, click on the toolbox. So you can see the different kinds of Windows tools that have come here, like button, checkbox. Okay, click on the pin button here, it gets pinned, and I'll drag and drop a button here, and I'll change the button to click me. Let it bring it a little bit down here, and then I'll drag and drop a text box. Okay, so whatever it is printed in this text box, we will pop it up here as a message. Okay, so now since I have to print something in the text box that is there when I click the button, so when I click the button, so when the event of button click has happened, I have to take an action on it. Okay, so double click on the button, so it has created an action for you, button 1 underscore click. That is how your button is named in the program, and you can prescribe a piece of code that has to be performed when there is an action. I'm saying message box dot show, and my text is available in text box 1 dot text. Okay, as we explained in the very first slide when we're talking about the .NET framework, we told that it's a rich object-oriented programming model, which means all these things what you are seeing on the screen here, your whole form itself is one particular class, button is a class, text box is a class, everything is a class here, everything is an object that at runtime. Okay, so now my piece of code is completed. When you click the button, I will pop up a message box and I will show whatever it is there in the text box. Okay, so you right click on this project, go on, click on build. Okay, so now I will go on, click on execute. Right? So when I click on execute, I am supposed to see my console based application is running. I am expecting my Windows based application to be run. Why is it so? Because when you are having a multiple projects in the application, when you have multiple projects in the solution, when you right click, so you have to explicitly specify which project you want to start within the solution, or you want to start all the projects within the solution. Okay, which if we say the startup, we call something called a startup object. If you are setting as a startup object, that will appear in a bold. You can see the difference here. Hello World console is coming in bold, but Hello World Windows is not coming in bold. So you can right click on this and you will have an option saying set up startup object, that bold switches from here to here. And you can see the Hello World Windows is coming in bold, and when you execute this, now your Windows application runs, not your console application. Okay, so and I'll print Hello World here and click. I can see a message box has been popped up and it says the Hello World. Okay, this is a simple GUI based application is what we have created. So we have told a So what would be the case? I want the two projects to be run at the same time. Okay, that is where you have to select your solution, click on the properties. This will open up you the properties of your solution. Okay, you have a single startup object here and you have a multiple startup. If you select multiple startup projects, you can say which should start here. So if I have selected start for both, which means both will be started in this particular order. Okay, click on apply, click OK, and when I click debug, okay, so I'll remove this breakpoint, take this forward. I can see both my Windows and console based application have come here because two solutions have started and both are running because of the setting what we have made now. So let us close this. Okay, let us go and inspect what actually has happened. Now we can see the dark, I mean like the bold letters have gone out of these two projects and just went to the solution. Why? Because this indicates there is a custom setting that was made to start up multiple projects. Okay, since we have two projects here, the solution itself is coming in a bold. So now let us go ahead and open up the Windows in the file system and see what actually different kinds of files that are created here. Okay, so you can see here there is a file that is created like CSPROG. This is called as a project file. So since it is a C# project, it is showing as CSPROG. It's a project file, and if we have hello world.cs and we have hello world designer.cs. So what actually the designer.cs holds? If you double click the CS file, you can see this is all the code that is generated by the Visual Studio for you whenever you are dragging and dropping the components onto the design pane. Okay, so let us drag and drop another button here. Okay, you go on to the designer, you can see the piece of code changes. You can see here the button 2 has come here. If I go here to the design mode and add, let's say I am adding a label. If I go back here, I can see a label has added here. So all this code in the backend is being generated by the Visual Studio for the actions what you are performing on the design. Okay, if you select your label and if you try to change the ID of the label, every object what you are putting in will have an ID. Okay, so this is basically put as a name. If I change it as like name label, okay, same will be reflected into your design again. You can see here my label name is changed to label. So this is what IDE is helping you to reduce your work, okay, by controlling the backend code for the front end action that are performed here. Okay, so now we can see here in the file system we have the project file, we have the program file, okay, and we also have a binary file. So this is again we are saying it's a deliverable and your assembly is hello world windows.exe. You can double click on this, it runs because it's a exe, it has a capability to create its own process and execute on its own. So let us go on use the ILSpy to decompile this piece of code and understand what actually it has created. So go to file, go to open and come to console, hello world windows, bin debug, and go ahead and select Windows hello world windows, and you can see hello world windows, and it has a method called, it's decompiling, it has a method called program. Okay, and you can see the main method is showing as an entry point. You also have a class called hello world. You can see there are different kinds of methods here, but no method has signed like an entry point. It's only the main. Okay, so how did this main come? We have not defined any main here. How actually it has come? It has come again as part of your template. You can see there is a piece of code called program. If you open that, you have something called as a main. Okay, and also you can identify the output would be a exe or a DLL by right clicking on the project, go to the properties. You can see here what is the output type: console based application, Windows based application, class library. If you change the output type to class library, you would end up with .dll and not exe. Whenever the output type is an application, that is where you will be getting an exe as a output. So that is what you can see here, the CAL. So if you try to convert this piece of code to VB, this is how it looks. Your VB code, you can see here. So the button click method again it has showing the message box dot show. Okay, so if you go and see your IL, what happens when your button click is what it happens here. It will load the field, load field from the text box class, and then it creates instance of string. Okay, so there are different kinds of MSIL based instructions. Okay, so that's it. We will, from this particular video session, let us quickly review and understand what actually we have seen in this video. So we have seen the .NET framework overview. So we understand the terminologies like CLS, CTS, CLR, MSIL, assembly, metadata. Okay, so we have seen the difference between the EXE and DLL. We understand what is an EXE and what actually is a DLL. Okay, so let us see the DLL also once, because when I click the EXE, I can see my process is running. So I've changed my output type to class library, and I'll save my project here, and then I'll build the project, and you can see here now my output has come as windows.dll in the same folder. So I'll go back here, go to debug, and I can see windows.dll. When I double click on this, you can see nothing happens here. Okay, because DLL doesn't have the capability to spawn its own process and run it. So this DLL has to be used into some other executable, and then it can be reused. That is why DLLs are always called as a class libraries, a reusable piece of codes. Okay, so we have seen the difference between EXE and DLL, and we have seen a very simple demonstration about one console based application and one Windows based application, and we have seen the Visual Studio where actually we develop the .NET codes, and we have also used a tool called ILSpy. You can visit the website called ilspy.org. So it's a kind of decompiler which will decompile your MSIL code back to the respective programming language, and you can view the IL code to understand what actually it holds, what kinds of information it basically holds.